The AM broadcast band goes from 540 kilohertz all the way up to 1700 kilohertz in the US. And I believe it's that way all throughout North America, actually. So amplitude modulation, what does that mean? Well, modulation, of course, means the imparting of information upon something. So if you're just speaking like I am, you can modulate your voice by talking louder or softer. If you're a singer, you can modulate your tone by using vibrato in your voice. But if it's an AM radio station, you impart information by modulating the carrier, and it's beyond the scope of the presentation to say how that happens. But basically, you have a single carrier frequency, say in the case of this transmitter, 640 kilohertz, and there's circuitry that adds audio to that by way of what we call modulation, amplitude modulation. There are limits to how much you can do. From a physical standpoint, the most you can do is minus 100%. And also, the FCC limits the positive modulation to plus 125%. So even though it's physically possible to do a lot more than that, and in fact, in the old days, that people used to do a lot more than that, until a commission made it a rule that you could only do 125% positive peaks. Now this meter right here is a modulation monitor for KFI radio, and you can see, as I mentioned, you've got negative and you've got positive, and we're not exactly hitting the limits too hard there, but you can hear how the modulation, how the audio correlates to the modulation meters.
Tomorrow we'll see a possible chance of rain in the morning, then highs in the upper 50s to mid 60s across Southern California. The Inland Empire will see highs in the low 70s. Tuesday we'll see cooler weather with highs.
Anyway, that's really all there is to it. Amplitude modulation, somewhat old-fashioned. FM modulation is different. The carrier frequency is actually changed. So the imparting of information onto the signal is done by frequency modulation. So instead of the carrier being exactly 98.7 megahertz, as speech goes on or as music goes on, the carrier swings back and forth in frequency. The receiver is able to detect that change in frequency and basically decode the audio that was started at the other end. So audio in on one side to modulate the carrier, transmission that we're all familiar with, and then decoding of the audio on the receiver, playing out your speakers on the other end.